Okay, so if you have any issues, please send me a message. I would attend to you. So I was giving a background. Solver is actually developed by a private company, Frontline. When you go to their website, www.solver.com, they are into other decision models. So these are a group of people who are applying the math that they learned in school. Unlike Amon, who decided to become a VLOOKUP expert. So that's Solver. It's a very powerful tool, but if you don't know what it does, you'll probably be going the hard way trying to find answers to your problems in Excel. Now, before we proceed, I need to be sure everybody has it installed. It is not installed by default.
How do you install it?
Okay, I'm going to go through shortly. So in the notes, I've given you steps, but you just go to File.
In any Excel file?
In any Excel file, yes.
Okay.
So you go to File, you go to Options.
Mm-hmm.
And then you see Add-ins.
Okay.
So File, Options, Add-ins.
Mm-hmm.
So when you click Add-ins, it will open this page, Excel Add-ins.
Okay.
You click Go, and then you check the box for Solver Add-in.
Okay.
We have the same thing for Mac.
I think so. Please go through the process. Let me know where you hit a block, and I'll see what to do. Now, for you to use Solver, there are some 3 key things you need to identify. The first one is the objective cell. Hello, is there a question?
Yeah, Bernard.
Yes.
Yeah. Why did we have to activate it? Why was it not already activated?
Okay, so these are add-ins. Add-ins are like, when you go to Google Play Store, some of the apps are not installed by default on your phone. They are extra materials.
All right.
Yeah, so.
Okay, thank you.
Okay. So there are lots of add-ins. Actually, beyond Solver, there are extra add-ins that you can play with. If you are using a very current Excel, when you go to Insert, you see there's a whole window shop for adding some elements, extra elements in Excel. So add-ins are like apps that people create to make life easy for Excel users. These are private developers. But in most cases, they are security checked, so they don't create bugs in your system.
Oh, okay, so they are all checked before.
Yes, they are all checked before. I think Microsoft goes through that security process to make sure they are safe to use. So add-ins, you can always explore what you have. When you go to insert add-ins, they are there. But the default ones are like Solver, Data Analysis Kit, all those add-ins. They've been with us since 2003. So now let's proceed. So I was saying that before you use Solver, you have to identify 3 things. First, the objective cell. The objective cell is the final result or the cell you are making a decision on. You are supposed to also identify the constraints. Constraints in the real world, resources are not free. And that is why actually people are paid to take up roles in organizations to manage resources. So especially in this lockdown situation where people are running shifts, a typical HR problem will be how many staff to fit in a particular role while maintaining social distancing. That is a constraint. And then the third one is variable cells. So variable cells are the cells that need to change. I say in class, you cannot make something clean without making something dirty. Something has to give. What cells have to move before you get what you are interested in? So these three things have to be in place. And as I go through the examples, you'll see what I'm talking about. So that is what solver is programmed for. In fact, it is part of the what if analysis family. And if you go to data and what if analysis, you realize that by default, there are three of them. Excel solver is classified as the fourth. So let's take an example of this goal seek model. So I've mentioned 1, your objective cell, 2, your variable cells, and then 3, your constraint cells. You have to get these 3 on standby. You have to identify them. Now, before you use any of the what if analysis tools, you need to have a model in place. What I mean by a model is that you should have some formula work at the back of what you are trying to make a decision on. So it can be as simple as finding revenue. How much should I sell, or what should be the price? So example, if you have 5,000 times 20, this can be a simple model. Just multiplying this and getting this. It's a model. Bottom line, you have dependent cells and then you have precedent cells. So what people normally don't get right is that before you even proceed to use goal seek, solver, or any of the what if analysis tools, you should have a well-connected model. And what I mean by well-connected is that if your decision is on these 3 cells, don't go and type this 100,000 sitting in isolation. Because if you run the model on these 3 cells, this third one is not connected to these 2. So it's very important that you get the model right in such a way that even if you play with your decision variables, some way, somehow, your output is responding. So that is very important. So if you look at this model, it's a simple break-even model. I'm sure everybody who is starting a business has gone through this before. And I'm sure most people will be starting a business in this COVID season.
Amen.
Huh?
I said an amen to that.
Okay, so now you have sales quantity. The input cells are the blue fonts and then the gray fill background. In our financial modeling class, you are used to this. And then for this purpose, the output cells, which are the formula cells, are in green. So let's quickly go through this model. You are planning something. It could be it can be a school, it can be a product, it can be a sobolo joint. So you, in your room, determine that you are going to sell 5,000. Each product is priced at 20. Now, to produce each product, you need to buy materials for 12 and then pay direct labor of 8. So the total variable cost to produce a single product is 20, which is calculated here. My revenue is a simple multiplication of sales and quantity. So this gives me 100,000. Now, my contribution margin in simple English is anything in excess after I have taken away my variable cost. Now, if you look closely, you realize that this business is not giving us any contribution because the total variable cost, what it takes to produce, and then how much we are selling it is the same. And if you are running a business like this, no matter how much you pray, you won't make headway because you are selling it at 20 and it's costing you 20 to produce. So your contribution margin is 0. And most businesses don't check this. At least you should have some contribution in order to turn a gross profit and eventually a net profit. Now, what we call profit margin is calculated here, which is your contribution margin over your sales. So currently is 0%. The list of items or costs that have nothing to do with how many things you produce is fixed cost. You take care of it anyway. So things like rent, those things are not part of your volume or it's not driven by your volume. So that is the fixed cost we have here, it's 50,000. And when you subtract that from your gross profit, you end up with your net profit. Now, this is a very simple model. It can be complicated, but at a very high level, these are the major blocks. We say you break even when you are producing enough to cover your fixed cost. So with this situation, we are not breaking even because whatever we are generating cannot take care of our fixed cost. And hence we cannot even proceed with this business. So you are the entrepreneur, you are at this point, and your question is, you need to change one of these, unit price or sales quantity. The one you can control probably is the price. So question is, by how much should this change in order to at least make me break even? So make me break even is a situation where this is 50,000 and then it swallows up this fixed cost and I get 0 here. Now, this is a particular example of a decision model. How much should I charge in order to get this profit to be 0? For something like this, a simple goal seek can solve it. I said again that you realize this model has all the cells connected. In fact, it runs through all the way from the top to the profit side. And that is why it is possible to use a decision model on this. If your model is disconnected, it will not work. You have some hard codes in there. Cells are not referencing themselves. This will not work. So in fact, in most cases, the hard work is trying to formulate the problem. And in some cases, it's just a simple plus minus equal to, just getting that right. So once you have that, just a minute, I'm admitting latecomers. So once you have that, you can now proceed with your decision. Now, this time we're not using solver, we are using goal seek. Goal seek works like solver. The difference is that with goal seek, you are allowed to play with only one decision variable. In this case, you can change price or quantity, but you cannot change both using goal seek. So if you have a situation where only one cell has to give, only one cell has to change to give you a desired output, goal seek is ideal. Now, it has 3 requirements. The first one is set cell. Set cell in this case is the objective cell. What am I trying to achieve? I want a situation where, so here you click inside the select icon, and then you go to your profit cell. So I want a situation where this C22, which contains my profit, is equal to 0. If it is equal to 0, it means I might break even. This is what we are trying to make clean. What are we going to make dirty? Or what should we change? We are going to change either unit price or sales quantity. So in this case, let's assume we are finding the right price. In fact, we cannot charge below this price if we want to survive in the market. So this is a one variable decision model. So if you are practicing with me, C22 is set to 0. I am changing C7, which is my unit price. Now, if I click OK, you did this in the room. Let's say all these things, you calculated them in the room before you went to the market. Now, you went to the market and then you realized that realistically, you cannot sell more than 4,000. You cannot sell more than 4,000. Now, I'm now moving to level 2, where we are throwing in constraints.
Mm-hmm.
So realistically, this cannot be more than 4,000. Okay. Now, at this point, question is, what should the price be for me to break even? Now, mind you, in the earlier case, our quantity was 5,000. But we now have a situation where we need to determine unit price subject to subject to a limited number of sales. So this is a typical constraint problem. You can have another situation where you went to the market and this material, you estimated that it's going to be 12, but the market is saying the least they can sell to you is 15. Now, the decision gets to a level 2 complication because it's not a straightforward, I'm selling this, how much should I price it? Now, these are what we call constraints. You are solving the problem, but there is some limit to the resources. So in a situation like this, we need to identify the 3 things that you need to do your solver. First of all, before you even do it, let's go to the checklist. First, you need to have a model, which is also called formula work. The second thing is you need to identify your decision variables. You identify your objective cell, and then you also identify your constraints. So first, this is checked. I have my formula work. Every cell is connected. My variable cells in this case is going to be 5,000, materials 12, and the unit price 20. These are the 3 variable cells that need to change in order to give me 0. Okay, so my sales quantity, my price, and my materials are my variable cells. What is my objective cell? It's profit. I need it to be equal to 0. And then my constraints are sales quantity should not fly over 4,000. And then the materials, the least I can buy that is 15. So normally it helps to set it out like this so that you know what to put in there when you start the solver. Once you have this set, you go to solver. it is best to always launch it in the worksheet you are working in. Normally, if you launch it on another worksheet, it misbehaves because it has some VBA elements that picks the current worksheet to load some results. Now, let's go through the dialog box. The first part, set objective. You are required to put the objective cell here. So the objective cell in this case is my profit. This is what I want to be 0. So that is my objective cell. So all you need to do is you click here, and then you come and select this objective cell. Now, when you click the objective cell, you determine what to make of the objective cell. In some decision models, solver can help you maximize. So it is going to give you the maximum value possible. You can choose this. Or you may be doing a cost reduction model. You can choose what is the lowest this can be. Or the third one, where you set the value. Okay, so the first two beyond you, the third one, you decide what it should be. So I'm setting C22 to a value of 0. This is my break even. So that is the objective cell. Now, the next one is changing variable cells. So which cells should I change in order to get this 0? So here you click, and we are looking for the input cells that need to change. So I select 5,000. If they are not in a contiguous form, like following each other, you have to press Control, and then you select the second one. So when you do that, you realize there's a comma between the first cell and the second cell. So Control select, and then the third one is this. So I have selected my variable cells at this point, C6, C7, and C9. Now, what is my constraint? I could solve this directly, but it will solve anyhow. I have to guide it because not all the resources are unlimited. So to add the constraint, all you need to do is you click Add. So you click Add, and you get this dialog box. Now, in setting the constraint, you can select the cell reference or cell references if they are continuous. And you can use any of these operations to set it. Remember, our constraints are we cannot sell more than 4,000. And then secondly, the materials cannot be less than 15 cedis per product. So these are the operations you do to set your particular constraint. So the first one is this 5,000 cannot be more than 4,000. So by this, I'm saying that whatever you put in here, you cannot put any figure more than this. Then you add. Now, when you have more constraints, you click Add. When you click Add, it saves what you have put in there. And then the things resets for you to add the second one. The second one is my material, which is in C9. The least they can sell it to me is 15. And here you can type it in, or you can select it from a cell. And then you click Add. Now, before I proceed, you saw some other options here. Aside setting some cells to equal to, greater than, less than, equal to, you can decide that the cell should be an integer. So let's say you are solving a model, or you're trying to find the optimum solution for a model. You don't want any fractions. You can say that C9 should be an integer.
Sorry,
That can-
Bernard, what is an integer again?
Okay. An integer is nothing. It's something that is not a decimal or a fraction. So 0, 1, 2, 3, 4.
Okay.
Whole numbers,
Okay.
negative or
Absolute
positive.
numbers.
So no
Okay.
decimals, no fractions.
Okay.
Mhm.
Back to primary school.
Okay, so you can decide that in solving or
Please,
giving
Dio
you a
is from
solution.
why?
Dio is from group 2. Okay, noted.
What does that mean? Some of us were art students, so you have to. Okay.
So an integer is a whole number, a positive whole number or a negative whole number. If you are dealing with dollars or cedis and you want to avoid all the fractions and decimals, you can say that in giving me a value for C9, make it an integer. But you see, if you are doing this, you have to add that as an extra constraint. Don't do, because already C9 has a constraint of greater than or equal to 15. So once you add this, you are supposed to come back and add this integer part as a third one. Okay? So that is what we have now. If you cancel, you go back to the solver. The good thing about this is that if you lose this, unless you reset, everything you have done is saved. So if you lose it, you can still go back to solver and you have it there, unless you decide to clean it. So currently, I have one constraint. I'm going to add the other one, which is the cell, which is the part and material cell, should be greater than or equal to 15. So if I am done, I'll click OK. If I want to add more, I'll click Add. So I'll click OK. So this is how it's looking now. I've set my objective to a value of 0. I expect these cells to change. The constraints are that C6 cannot be greater than 4,000. And then my material cost is greater than or equal to 15. Now, you can add more constraints. You can change them if you change your mind by clicking and editing. So it will just bring you this for you to change whatever you want to do. When you are done, you have this checkbox here that all other unconstrained variables, the other cells, okay, you see, when you are solving, you can end up solving the same problem with negative numbers. When you check this box, it restricts solver to positive numbers. So by default, this is checked. Then you come to select the solving method. And this is where we go into a bit of math. So in using solver, it is built to take linear equations. It is also built to take linear and smooth math equations. Not to bore you, these two are always fine. The non-linear and then the simplex LP. In most of the cases that we use solver, any of these two is fine. So if yours is a straightforward case, you can use simplex LP. If you have some points that are not smooth, you can use the GRG nonlinear. But in most cases, the first default one is fine. You don't have to bother about this. So when you are done, you click solve. And let's see what we have. So solver now gives us a solution. It found a solution. If it didn't, it will say it didn't find a solution. All constraints are satisfied. Now let's look at what it did. It replaced this with 4,000. It changed the materials to 15. And then it is saying that in order to break even, we should be charging 36 from our original 20 something. Okay, so that is the solution that it gave us. Now, if you want it, you can click OK. If you like, you can cancel and restore to original values. Or if you like, you can even create a report out of this for you to discuss further with your boss. So before you even click anything at this stage, there are options. You can click answer to print out the answers in another worksheet. So all you need to do is just click answer and then you click OK. It will create a new worksheet for you. It can also give you a sensitivity report. So it will give you the limits of the solution in another report. And then you can also add that. So all these, depending on the report you want, all you need to do is just click and then you click OK.
But I didn't get the sensitivity and limits on mine.
Okay, so let me illustrate. I want this solution to be printed out. So I have answer and sensitivity checked. And then I'm going to click OK. So in the answer report, it's going to give me this report. So every detail I put in there. So my objective cell was originally 50,000. And it has given it a final value of 0. These were my variable cells before and after. These were my constraints. Okay, so it's like a secretary printing out everything that you did for you to further analyze this. Now, sensitivity report is basically using some math language to explain how it arrived at these results. I'll be honest, I don't want to go into the technical details on this one because I'm not sure I get how it got this value.
No, I mean, under the reports, I just got answer. I didn't get sensitivity and limits.
And your Excel is from Microsoft.
Yeah.
It's a crack version.
Okay, let's do it again. So solver, solve. If I got to.
Let me add something small too.
Okay, go ahead, Ernest.
Yeah. So launch the. It's okay. You see this. No,
let me come back here.
Okay.
Mm-hmm.
So this thing actually, those of you who are very comfortable with linear programming, this tool was actually made for linear programming. You know, where we deal with a lot of variables and non-negativity constraints and all of that. I don't know how many people are comfortable with that kind of mathematics, but that is what it actually does. So if you look at the make unconstrained variables non-negative, that is that non-negativity variable that we usually do in linear programming, where you have to calculate and calculate and calculate, you know, depending on the model, the approach you are using. And when you come to the select solve, you see Ben has chosen the GRG non-linear. So this one, it's non-linear, but usually with the simplest, you know, we have the simplest and the duplex. It's some kind of mathematics that it's very difficult. So the simplest linear programming is the second option. In fact, the evolutionary, I don't know, maybe the non-linear one, and then the simplest linear programming approach one is the second. So that is what this one does. So those of you who are into research, who do a lot of research, and you, especially for the economic people who do econometrics and a lot of statistics and all of that, this is very, very, very helpful. It solves that problem of solving. I don't know how many of you have had the chance of calculating it, you know, in mathematics. It's too long. That I'm not sure you want to subject yourself to this. So this actually does a great work in your constraints. So you can use it. Those who are in economics and research and all those maths.
Okay.
Thank you,
Ernest. So I'm back to the question that you said you are not seeing the other reports here.
Yes,
it
I
Joseph?
wasn't. No, it was Ellie.
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 Uh-huh.
Yeah.
Are they still there or they are gone?
They are not there at all. Or should I recalculate it?
Yes, recalculate. Because under normal circumstances, you should have 3 reports.
Okay.
Uh-huh. Now, you don't always have to save the final answer. The other option you can do here is to save this as a scenario. In fact, Solver allows you to save this as a scenario. So you can save and then name this maybe the scenario name is material parts. Material is greater than 15. Material is greater than 15. So you can save this as a scenario. Okay. And then.
Yes, Bella.
Okay.
Yes.
So at this point, I'm expecting everybody to go through the process and then arrive at my current situation.
But when you save the scenario, where does it save it to?
Okay, so when you save a scenario, you can find that under Scenario Manager. Okay. So if you save a scenario and you go to Scenario Manager, you see all the various scenarios that you saved. Okay. So you can click Show because I have only one scenario here. In fact, what I could have done was I could have saved the scenario before okaying it or accepting this one. Let me see if I can do an undo. Okay, no, it doesn't give me an undo option. But it is best to solve and then save as a scenario before you accept. In fact, if you save as a scenario, you don't need to accept because it is loaded in its memory under Scenario Manager. If you have more, all you need to do is click here and then you click Show. And then the various inputs will now play here.
Bernard.
Yes, sir.
Yeah, the variable cells. Why is labor being left out? I know you are saying the variable cells are the input cells. Why is labor being left out of it? I understand the constraint being the 2, but labor is standing alone and it's not part of your variable cells. Can you just go over that?
Okay, so the reason I didn't add the labor is I did in my simulation, labor wasn't a factor, but you can add labor if you want labor to also change.
Okay, okay.
So bottom line, if you don't select it, it means you are allowing it to be constant.
Okay.
But if you change it, if you add it, it means it should be part of the simulation.
Okay.
Mm-hmm.
Okay. Thank you.
Bernard, question.
Yes, you.
My question is on goal 6. I wanted to find out if, for instance, if your objective is to modify a growth rate, so in percentage, by maybe delivering a certain volume. And I mean, can that also work? So what we worked on earlier was mainly to look at what price, what unit price to sell to have break even.
Mm-hmm.
But if you were to look at what growth rate, let's say from last year to this year, what growth rate should we pursue to break even, for instance? Would that also work?
Yes, that will work. That will work because I'm assuming that when you do that model, the growth rate is already part of the formula work. That is 1.
Yes.
2, the growth rate is part of a variable cell. Okay. And then your objective cell is again your revenue or your sales. So in goal 6, what you are saying is that change my objective cell by changing the growth rate.
Yes.
It it should work and give you the optimal growth rate to achieve what you are interested in.
Okay. All right. Okay.
This is a similar question, but Bernard, I'd like to know. So, for instance, if I want to say that in the variable cell, I would want to put a constraint at a percentage of the price. Is it not the price? As in a percentage of the the material cost.
Mm-hmm.
How would I do that? So, here we said it shouldn't go beyond 15%.
Mm-hmm.
15. But if I would like to say that it shouldn't go, it shouldn't be more than 20% or a percentage of that, how would that work?
Okay, so in that case, let's go back here. So let's say it shouldn't be more than 20%. Right, this is what you are saying.
Yes.
So in this case, instead of typing this 15 here, I've used a formula to derive the limit. So all you need to do is when you go to solver, you now come and edit this.
Select that limit.
Okay, so I'm going to change this and then say this should not be more than this. So you are not forced to always put in a number here. You can direct it to a formula work. Do you get it?
Yeah, I do.
Yeah. So you can point the constraint to a formula work, in which case this is the 20% I have calculated. So I'm saying that C9 should not be greater than or equal to F9. F9 is calculated as 20% off a certain cell. You can do that. So let's see if that even gives us, yes, we have a solution with that. Did I choose greater than or less than? Let me choose less than and see.
That's saying we should sell at 21 cedis.
Yes, it's now saying we should sell at 21 cedis. So the equation is met because this is actually less than. Okay, let me quickly do this and we are out of here. Now, we have this model. And again, we need to turn a break even. So the break even is where this is equal to 0. But unlike the first one, we are dealing with 3 products now, each with their unit price, material cost, labor cost, their total variable cost per unit, their revenue, and their contribution margin. Now, at this point, we are not turning a profit. So we need to calculate break even where all the profit is 0. So first of all, let's go through the 4 things that we need to check. The first one is I should have a model in place. The model in place means that every cell is linked. If that is checked, the next thing I need to do is I identify my variable cells. So my variable cells is at which price should I sell these items? So these are going to be my variable cells. And then my objective cell is my profit, which is supposed to be 0. Now, currently, I don't have any constraints. But when we solve this, it will probably give us reason to put in some constraints. So let's solve this. I go to data, I hit solver, I get a clean sheet. Now, my objective cell is this profit. I promised it was going to be 1 hour, but because of the light issue and then the latecomers, please spare me an extra 10 minutes to finish this up. My apologies.
That's okay.
Yeah. So set objective to a value of 0 by changing this price, and that price. So my changing cells are unit price for product A, unit price for product B, and then unit price for product C. What do I want? I want I-29 to be 0. Now, let's solve this without any constraints. So I solve this. Solver found a solution. Now, if you look at this closely, you realize that solver decided to push the weight to product A. And then in the process of getting a final 0, made product B and C negative. I mean, if it effectively satisfies our equation because at a very high level, we have broken even. But you cannot break even while some of your lines are reporting negative. So I said that sometimes when you solve a problem, looking at the solution, you may have to revise and then put in some constraints to help solver get the right decision. So what it means is that we need to go back to the drawing board and put in some constraints. Can anybody suggest the constraints to add so that this, that, and that should not return negative numbers? So any suggestion? What constraint can we add?
Hi Bernard, I think that we can add that should be those particular cells should not be less than 0.
Thank you. So to fine tune that solution, we can add an extra constraint that in solving this, get a 0 all right, but don't make these guys anything negative. In fact, the optimum solution is that this should be 0, 0, 0, and 0. So we have to go in and add these constraints. Constraint is these should not be 0. So I go to solver. What I can do is that I can save this current one as a scenario. So I can say that, okay, for this particular one, save it as where the weight is not evenly spread. Okay, so that is a scenario. Now, we come back here and then we add a constraint. So add a constraint. The constraint is that in solving, C29 should be equal to 0. Add this E29 should be equal to 0. Or if you like, you can even amend it and say it should be greater than or equal to 0. So let me click OK and then go and edit this. So greater than or equal to 0. Okay. And then this change greater than or equal to 0. Add. And then the last one is that this one is greater than or equal to 0. Okay. So I have amended this. All the other remain the same. And then I'll solve this. So I'm going to save this scenario as weight is spread, no zeros. Okay. If I like, I can click OK or I can click cancel. It is saved already, so it doesn't matter. Okay. So I'll click OK. Now, if I go to my what if analysis and I go to scenario manager, again, I see the two options where the weight is not evenly spread, show. Okay. Where the weight is spread, no zeros, show. So this is an effective way to explore more options, adding constraints, taking away some, but you can save and show them separately in your presentation. So that is about that. Can you give it a shot? If you have any questions, please, you can ask and then we'll go through it. So again, the application is when you are at the office, you create a budget or you create a purchasing order model, something like that. Anything that you will be playing with the blue numbers to get a certain target. Fine-tune that, fast-track that process by using GoalSeek or using Solver. You can fine-tune it by giving yourself constraints. Identify your objective cells, identify your variable cells, load it into Solver, and then save the various scenarios. So that is Solver. And I must say that there are complex ways you can use that. See how it goes. Any questions?
Question Bernard.
Okay.
So I noticed if sometimes you maybe you click OK. With Solver, you click OK, and the answers you get, it's not maybe exactly, or you made a mistake in choosing one of the cells. So you want to revert, the process, and it's like it doesn't give you room to do that.
Okay, so if I got to, you clicked OK.
And then
normally,
So when you click OK, you get the answer, or maybe the value, the solution. You get a solution. The blue part gives you some solution. But then perhaps during when you're keying in the inputs, you choose the wrong cell, and therefore the solution you have is not. You cannot work with it. You need to go back to correct something. But so you don't have an option to revert, or maybe I don't know how to do it.
I mean, the advantage you have with using Solver is that anytime you go back to the Solver menu, unless you have reset it, whatever you used is saved for you.
Okay.
So if you made an error, it allows you to go back and change that part and solve again.
Okay.
So it's that flexible. And that's why I advise that any solution you get, as much as possible, check first before you click OK. But you can save it as a scenario and then play it back later and cancel. So there are options for you. You can save as a scenario and cancel, it will be stored. Or you can check. If you like it, you keep it. If you don't like it, you click restore to original values, and then it will do that for you. Normally, if you click OK and you don't save it, in most cases, the undo doesn't work. So you always have to be careful at that final stage.
Okay. Okay, great. Thank you.
Bernard, I have a question.
Okay.
The options under constraints, if you want to change constraints, the middle there where we have integer, I want to know what the other two options are. Is it binary and the DIF, the DIN and the DIF? What do they mean?
Okay, so the integer is the whole number, negative or positive. Binary is you want the answers to be strictly 0 or 1.
Okay.
You can add that as a constraint. And then the different DIF is when you select a range of cells and then you want it to solve without repeating a number. So that means all the values, when you solve them, should be different.
Okay.
So you don't want like a 224. You want a 256.
Okay.
So those are the other three options, but the rest we know. So integer, binary, and then DIF.
So in this case, if we had put a binary there, okay, that's we got a 0. So can you just elaborate the binary 0 or 1 a little?
So the binary 0 and 1 means that it is limiting the answers to only 0 and 1. It cannot be any of these numbers, any other number apart from 0 and 1.
Okay.
So in fact, it's not a very common model, but there are some models where you are just trying to output only 0 and 1 when you are solving. So in that case, binary is more effective.
Okay. All right, thank you.
Okay. Any other?
Yeah, Bernard, I have a question.
Okay, Nora.
Assuming you're done with everything, you
Mhm.
actually accept the scenario and you have maybe all zeros like you currently have.
Mhm.
And then you want to go back to the original, like where the cells, the zeros they actually hard coded. You want to go back to formula. You want to see what happened. Can you do that?
Okay, so again, best practice will be to save your different outputs as scenarios so that you always have your original work intact. The moment you override your original work and accept, the only savior is that the sheet is not saved. You can always open the sheet without saving. But please ensure that if you want to get the original data, don't override it. I don't know if it makes sense.
It makes a lot of sense. Thank you.
Okay.
You can just move it out and work on them.
Another option. So you can just duplicate and work on them. That uses more fuel. Okay. Any other? Okay. So if there are no questions, I just want to do a quick recap. So this topic was just to give us an idea on Excel's what-if analysis. We have some default 3 here. In fact, in subsequent Saturdays, we'll look at data table scenario manager in detail. But today, what we did was solver. And we said that it is not always there. You need to go to File, Options, Add-ins, Excel add-ins go, and then you check solver add-in. In fact, those who do statistics, this one, you can add it as well while you are here. Analysis 2-pack for correlation and regression and all those calculations. So those two can be activated. You have them here. Solver is to optimize and help us simulate, get decision variables. So when you are using assumptions manually, you can use solver to fine-tune that. So we did a basic example of the junior brother of solver, which is goal seek. We normally use goal seek when the decision variable is only 1. We are changing that decision variable to give us an expected output. So we did it on this one, where we wanted to know the price we should charge to break even. And then we used solver to check a situation where we have constraints on sales quantity and material parts. So once the decision variable becomes more than 1, then you have to transition to solver. I said that in order to use solver, there are 4 things. You should have a working model, formulas linked. You should identify your decision variables. You should identify your constraints, and then you should identify your objective cell. Decision variables are the cells you can change manually. Objective cell is the output, the formula. And then the constraints are limits you put in the solver to fine-tune your results. In the real world, not all resources are free. So the constraints will help you fine tune your problem. You can save solver outputs as a scenario. You don't have to override your original one. So once it solves and it gives you this page, before you click OK, please check and make sure you're okay before you hit this. Otherwise, it overwrites it. Best way is to save it as a scenario and then cancel afterwards so you have your original work. You can always go back and play it. So thank you for your time.